Hi, I'm Rob, and I'd like to welcome you to the next video in the AI on AWS playlist on the Cumulus Cycles channel. In the prior videos in the playlist, we learned about the AWS purpose-built AI services, then got an introduction to Bedrock, and built a simple chat app that demonstrated integration with the Bedrock Invoke Model API using Streamlit and FastAPI. In this video, we're going to look at a complete full-stack multimodal AI chat app with Amazon Bedrock using FastAPI, React, and TypeScript. Before we get started, I'll mention that all the code for this app is in my GitHub repo, which I'll provide a link to in the description below. Also, you'll need an AWS access key and secret access key to programmatically access the Bedrock service, as well as request access to Anthropic models in Bedrock if you haven't done so already. If you're not sure how to do this, see the prior video in the playlist, as I've covered everything you'll need to get started here. Now, before we jump into Cursor, I want to mention that I had originally planned to walk you through building this app out from scratch. But as you can see here, there's a lot of code. And to do that step by step would make this video several hours long. So in this video, we're going to walk through the code to get you started. Then I'll create an entire playlist which will contain a series of videos building this app from scratch. So if you're looking to take a deeper dive into the build after walking through the code in this video, keep an eye out for that playlist. Now let's jump into Cursor and get started. First of all, in the README, we see a quick start guide for initializing the app. So I'll open a terminal in the backend folder, then run the UV sync command and activate the virtual environment. Next, I'll create the .env from the .env example file. And then looking at the .env file, we see variables for the AWS configuration. We'll specify the region, add your access key and secret access key. We've set the Bedrock model ID for Anthropic Claude Sonnet 4. We have the API configuration for the backend server and default chat parameters for temperature and max tokens. Now I'll open a terminal in the chat frontend folder, run npm install to install the dependencies, and then create the env file. And if you look at the .env, we see a variable for the vAPI URL, which points to the backend server. Then I'll do the same for the admin front end. And looking at this .env file, again we see the vAPI URL and a v polling interval set to 15 seconds, which refreshes the admin dashboard to pick up the current stats. Now let's go ahead and launch the app. First, I'll go into the backend terminal and run the command to launch the FastAPI server on port 8000. Then jump into a browser and load localhost 8000/docs, and we see our endpoints. Now jump back into the chat frontend terminal and launch the app using npm run dev. Go back to the browser and load the app on localhost 3000. And finally, we'll go into the admin front end and launch that app, which we can access on port 3001. Now let's go ahead and test this out. So I'll start by entering the accident description text, and then add the images. And submit the assessment. And we see the response. And now we can ask a follow-up question. And we see that response. And if we ask an unrelated question, we see that response. Now let's jump into the admin dashboard, and we see metrics for our conversations, total messages sent, total tokens, and so on. The rest of the README presents the architecture, configuration, and testing. And I just want to point out that in the backend folder, in the Postman folder, there are Postman environment and collection files you can import for testing the backend APIs if you're interested. Now let's start looking at the code, and we'll begin with the main Python file in the backend folder. The backend server is a FastAPI application that exposes REST endpoints for damage assessment, conversation management, and admin analytics. It integrates with AWS Bedrock to perform AI-powered automobile damage assessments. The main Python file is the FastAPI app entry point. It sets up cores and includes routers. The core's origins for the middleware are defined in the root config file. And here we see the core's origin string is being populated from the .env file, which we see here is wide open, which is fine for this local demo. And while we have the config file open, let's scroll to the top and see we have variables for AWS region, the default model ID, default temperature, default tokens, and variables for the images. This is also where the Boto3 Bedrock runtime client is created. And if we scroll down, we see the system prompt message, which is sent to Bedrock with every chat request. Take your time and read through this, as it's key to getting the model to perform as an expert automobile damage assessment specialist. Now let's take a look at the routes, starting with the chat route in the routers folder. This Python file implements the chat endpoint, which includes the core Bedrock integration. Here we see it imports the Bedrock client, system prompt, and default model parameters from the config. And it imports chat message, chat response, and content block from models. So let's take a look at those. In addition to defining the classes which we just saw imported into chat, the model's Python file also defines other classes which are used throughout the app, all of which inherit from base model, which comes from Pydantic. Starting with the chat messages class, we see this defines a single message in a conversation. It has a role, which indicates who said the message, either the user chatting with the system or the AI assistant. Content is the actual message body. It can be a simple string or a list of content blocks, which we'll see in a second. @class method marks the function that follows it as a factory on the class itself. So here you would call this function as chatMessage.FromText instead of on a single message instance. FromText is a helper function that builds a text-only message. You pass who said it, the role, and the text. It creates a chat message with that role and the text as content. Multimodal is a helper function that builds a message that can include text and/or images. You pass the role and a list of content blocks, and it creates a chat message with that role and those blocks as content. Looking at content blocks, we see it could either be a string or a richer type of context like text plus images. So basically, looking at from text and from multimodal, from text makes a simple text message, from multimodal makes a message that can have text and images. The chat response class defines the shape of the data that the backend returns when a message is sent. It contains the message, which is the actual reply text from the model, the model ID, which defines which Bedrock model was used. Usage returns how many input tokens, which includes the prompt and history, and the output tokens, which are the reply, used in the request. And the conversation ID is the ID of the conversation that this reply belongs to. So basically, the chat response is the model's reply, the message. The model ID is which model produced it. Usage is how many tokens it used. And conversation ID defines which conversation it's in. Jumping back into the chat Python file, we see the next import is from storage. So let's open that file. At a high level, this file implements the single in-memory store for all chat conversations with Bedrock. It holds the full conversation objects, including the messages, and it's used by chat to load and append messages, create new conversations, and persist replies. It's used by conversations for user-facing operations, and it's used by the admin UI for analytics, timelines, and model stats. It defines global variables for conversations and the conversation lock, and it imports conversation response and conversation summary from models. Here we see that the conversation response class defines a model config using config dictionary, which is Pydantic's way of setting operations for a model class. It's the configuration for how that model validates and behaves, as well as defines properties for the object, where messages is a list of chat message objects. And conversation summary is similar. Back in storage, we see function definitions for get conversation or 404, verify user ownership, get all conversations, build conversation response, and build conversation summary. Jumping into the get conversation or 404 function, we see it gets the conversation using the conversation ID. If we have a conversation, it returns it. The verify user ownership function checks to see if the user ID on the conversation is equal to the user ID passed in, and if not, it raises an exception. The get all conversations function returns the list of conversations. Build conversation response returns a conversation response with the associated properties. And build conversation summary returns a conversation summary with its properties. Now, back in the chat Python file, we'll look at the chat function for the chat endpoint. Now, this function is really where the rubber hits the road when it comes to Bedrock integration. And here's what it does step by step. It handles request parsing by reading the request based on the content type, which is either multi-part form data or application JSON. If it's multi-part form data, it has a user ID, message, conversation ID, the model settings, and file uploads. If it's application JSON, it has a user ID, a message, the conversation ID, and doesn't include any files. The function also handles validation for both initial and follow-up conversations. If there is no conversation ID, it treats it as an initial damage assessment and requires exactly 3 images in addition to the text description. Otherwise, it's a follow-up, and files are optional. It performs user message assembly by formatting the chat message for the Bedrock Converse API, sets inference configuration for the model, populates the system prompt, and then makes the call to the Bedrock, passing the assembled parameters, and stores the response in a variable. It then extracts the output message from the response, and for each content block in the output message content, it appends the text to the assistant message to retain context. The usage data is extracted to be stored and displayed on the admin UI. Then, if we have a conversation ID, it sets the properties on the conversation, else it's an initial submission, so a new conversation is created and returned. And finally, it returns a chat response with the assistant's message, model ID, usage, and conversation ID, either new or existing. Back in the main Python file, we see an import for the conversations Python file. This file provides REST endpoints for managing conversations scoped to individual users. The create function creates a new empty conversation with a unique ID, timestamps, and default settings. It stores it in memory and returns the full conversation object, and then the client uses the returned conversation ID to send messages via the chat endpoint. List conversations returns all conversations belonging to a given user ID. Get conversation fetches a single conversation by ID, including the full message history. And delete conversations removes a conversation from storage, verifying ownership by the user ID before deleting it. The imports from storage provide the conversations data store, thread safety using the conversations lock, validation helpers, and serializers to go from dictionaries to pydantic models. And the admin Python file provides several endpoints and associated functionality for reading from storage to obtain data for populating the admin dashboard. So now that we've walked through the backend, let's discuss how the Bedrock integration with the FastAPI works. So end-to-end, at a high level, this system connects a chat client to a FastAPI backend, which orchestrates calls to Bedrock using Anthropic's Claude model. There are two main flows, the initial assessment and the follow-up process. Starting at the top, the user interacts with the chat UI. Each message is sent to the backend through the chat endpoint request. The backend validates the input, builds the request payload, and then calls Bedrock using Claude via the Converse API. Bedrock then returns an AI response, which the backend stores and then sends back to the client. For the initial accident assessment, step 1 is for the user to submit a text description along with exactly 3 images, which is the multi-part form request sent to the backend. Step 2 is when the backend validates the request, specifically enforcing that the 3 images are required for new conversations, as well as a text description, and then builds a message payload that includes both the text and the images. For step 3, the backend calls Bedrock with a system prompt designed for expert style analysis. This is where Claude performs the core reasoning and analysis. And finally, step 4, the backend stores the response and the conversation state, then returns both the AI's answer and a conversation ID to the client. In the follow-up flow, the user sends a follow-up message, which includes the conversation ID and the user's text prompt. So first, the backend loads the existing conversation history using that conversation ID. Then it appends the new user message to the conversation context. Then the backend calls Bedrock again, this time sending the full conversation history so Claude can generate a contextual response. And finally, the updated conversation is stored and the AI's reply is returned to the user. Now, before we wrap up this video, I'm going to show you the code in the chat front-end React app, which integrates with the FastAPI backend server. Starting with the app.tsx file in the source folder, we see there's an import for the chat interface. This is used to render the chat interface component on the UI, which we see on line 44. In the chat interface file, we see several functions, but we'll focus on 2, the submit initial function and the submit follow-up function, both of which use the API service, which is imported above. And jumping into the API file, we see the send initial and send follow-up asynchronous functions, which make calls to the API base URL, sending the user payloads. And when the response comes back from the back end, it returns the chat response and data back to the caller. The admin front-end React app also makes calls to the API base URL to request data to populate the admin dashboard. Okay, so that concludes this look at a full-stack multimodal AI chat app with Amazon Bedrock using FastAPI and React. I know we just skimmed the surface on the front-end code, but honestly, all you really need to understand is how to make the request to and handle the response from the back end. And then you could put any UI in front of the app that you want to. We obviously spent more time looking at the back end because that's where the integration with Bedrock happens. And although we didn't look at all the code, we did cover the key components. So with that review and the code in the repo, you should be able to spin this app up and test it out. Assuming, of course, you have your AWS access key and secret access key, the right IAM permissions, and you've requested access to the Anthropic models. As I mentioned earlier in the video, I'll work on putting together an end-to-end playlist to build this app from scratch as time allows. Well, as usual, if you found this video interesting, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. In the next video, we'll take our first look at building a RAG application on Amazon Bedrock using knowledge bases. Thanks for watching.